Alright, now in this video we are going to make few very simple basic circuits of PLC. First is a series circuit, two series input, right? For that, let's take some inputs here. I'm taking I1 and I2. Okay, let's take I3. We have to connect these in series, so that's how you have to connect one after the other. Okay, output of one goes to the input of others. So connecting that to one output, taking as Q1. Sorry, not this one. Actually, it's this one. So this is I can write here, series input circuit. Alright. Now what will happen in that? Go to simulate and go to run. Now if I press both the inputs, then my output will be on. It's very simple. Now if you see this red color means the signal is coming from here and it is right now blocked here because this contact is open. So if you press this one, your output will be on. You can see here because this whole red line coming from here to the end. So that's the series input. If I open any of the input, output will be closed. Okay, this is called two series input. Now if you want to make the parallel inputs, go to simulation mode again, and you have to take this over here and connect like this. Now in parallel inputs, you know that if I press any of the input, output will be on. So let's just check this one. Quick and easy. I have to run this. If you're not running that, it will not show you the results. So the output is on here, Q1 is on, with this one also, and with I3 also. So this is called series input. This one is the parallel input. Okay, so let me just differentiate these. Should go here. This is a series input circuit. Parallel input circuit. For that I can take further inputs like I4. I can take I5, connecting in parallel. Okay, I should take in sequence. Let me just take I2 here, I3 and I4. So connecting that in parallel like this. This will go to next output, Q2. This is parallel input circuits. Now if you want parallel output circuit, in that case, let me take one more input, I5, connecting 9. Now I can take Q3 and Q4. Now these are connected in parallel. So here I can write parallel output circuit. Okay. Now if I go to simulation, run. Now here you can see that the upper part is still clear. This is series input. This is parallel input. Any of these, output will be on. Now with this I5, you have two outputs to be on. This is parallel outputs. It's very easy to understand. Okay, so this was some basic series parallel circuit. Now let's do the latching and unlatching. Okay, so the latching I can do here. Latching circuit. In latching I should take I6. I'm having this I6 over here. Okay, now we know that in latching if I press this once, my output should be on continuously. So let me take an output Q5. I want to latch this output, means it should remain on if I even release this I6. So in that case I'll take the contact of Q5 just below this I6. This will make it a latching. Okay, now let's just simulate and let's just see how does it work. Now this is my I6. If I press I6 once, okay, let me just press this. This I6 is turned on the Q5 and this Q5 contact is closed because the addressing is same. Now even if I release I6, this will remain on. This lamp is remain on because this is giving auxiliary supply to Q5, this contact. This is the contact we are using here. Okay, this is the virtual contact. We don't have this contact physically, practically, but it's virtually inside the software, inside the PLC. So now to unlatch this output Q5, we have to add some NC contact here to unlatch this Q5. So for that, let me take one more input, I7. That should be NC. So I'm pressing spacebar. Simulation, run. Now see, this is latch using IC. Now if I open this one by pressing this, it will be unlatched. So this lamp over here, Q5 is latched, unlatched. This is again latched, this is unlatched. So that's how you can latch and unlatch the outputs using two push buttons. And you know, if you have NC, external NC switch outside the panel, we are assuming this buttons as connected to the PLC, as these are connected to the PLC. All are NO push buttons. In case if you have NC push buttons, then you have to take NO here. That should be vice versa, right? That concept you can understand from my other video of difference between NO and NC contacts and other delta and elemental lessons. But here I'm just explaining you. You can find more details in other videos. Alright, so this was about latching of my outputs in this PLC. Now let's go for interlocking. Okay, now there's another very important concept, that is interlocking. So let me just remove this circuits from here. Now let's suppose my task is I'm having two buttons, I1 and I2, and parallel to that I have two outputs connected like this. Now my task is to interlock these outputs. Interlock means if I am turning on this one, this should turn off this output. Okay, now if I turn on this output, this should turn on this output. So they should not be on, you know, simultaneously. Either one of these should be on. That is called interlocking. One is locking the actuation of the other. That is interlocking. So how to do that? In that case, let's first do the latching. So here I'm using contact of this Q1 to latch this one. Okay, this is the latching of Q1, and to latch this one, I'll take Q2 here. This is the latching of Q2. Now, I want that using this contact, using this output, I should unlatch this Q1. So in that case, I'll put the NC of this Q2 here, over here, because this will break the latching. So I can take Q2 here, and I'll press the spacebar. This becomes the NC. Similarly, to unlatch this by actuation of Q1, I will break this latching. So for that, I'll take NC of this Q1 over here. That's it. This is called interlocking. Let's see how this works. Going to run. Now you have these contacts here. Now this Q2 is already, Q1, Q2 contacts are already closed because these outputs are off. So I'm going to turn on the first one like this. So I have pressed and I have released because this has latched. So this Q1 is on over here in the discrete output section. You can see that. Now just see here, this Q1 is on. This has opened this contact Q1 because this was NC, and this is getting on. So NC become open. In that case, this is off. This is NC. That's why it is closed. But this is on. That's why this NC contact is open. So if I press an I2, what will happen? This will be on, and although this is NC, this will open this contact, so it will break the above latching like this. Okay, so the first output is off because it has break the latching. So similarly, if I press I1 now, this is Q1. This will get on. We have to stop Q2. This Q1 and Q1 is similar, same addressing. This will open this contact, which will delatch this circuit, which will unlatch the circuit like this. So this is how it works. You have done the interlocking. You can do the 3 interlocking as well. This is interlocking of 2 outputs. You can do interlocking of 3 outputs. Okay. Now in this case, you have seen that both the outputs are on, or you can say that either of the outputs are on in any situation. Now I need a third switch to stop the outputs, to unlatch both the outputs using one switch. How can I do that? For that, you can take here I3 NC here as well. We can take multiple contacts of same inputs. That's the flexibility we have here. So now this will work as interlock as previously, and this I3 is going to turn off. It will going to turn off the interlocks. That's how it works. Okay, so this was kind of interlock circuit which we can make using simple NO and NC contacts. I hope this concept is clear up to here. Now I have some more different commands to make this logic even more easy. Okay, so let me just go to edit mode. I'm erasing that. Now you find this symbol here, S, latch activation. Okay, how to use this one? So now instead of this contactor output, I'll take latch activation. Okay, let's take this one first. Impulse output. Now this is a very important special command in Schneider PLC. You may not find that in LM8D and Delta and other PLC, but this is a special impulse output. What does it mean? Let me just show you instead of explaining that. This is an impulse output. It will turn on as soon as there is a pulse at the input. It will latch itself. Okay, so I'm pressing this I1. Let me go to run. See, I1 is pressed and I1 is released. This has been latched. Now if the second pulse comes, it will unlatch like this. So using only one input, I'm turning this on, I'm turning this off. That's how it works. It is just toggling the state of this Q1. It will toggle the state. Whatever state it was, it will get toggled by this pulse of the input. And that's how it works. This is the impulse output. You can use that in many of the situations. You have a small motor which you want to turn on using the same input. You can put a push button on your panel. Using this command, you can turn on your motor using the same input. So that's where you can use this one. Okay. So now coming to the interlocking using special commands. So instead of this impulse, I'll take here set. This is similar to impulse, but the difference is it will remain set. It will not get reset by the same pulse. To reset this one, I need to use the reset part of this bit, this R. Okay, let me just have it here. So I'm going to take one more input, I2. Using that, this will get reset. So this will get latched and unlatched without using the auxiliary contacts at the bottom of the inputs. Now you can see that if I press I1, the output is latched here, Q1 is on. By pressing I2, this is unlatched. Okay, and you must know that the priority of this command is the reset. If you're pressing both, it will reset the output, although it will show red here, but the output will be reset because priority of reset is always high. But if you work on Ellen Bradley, there is two types of set reset, RS and SR. If you're using RS type set reset command, in which reset is dominant. If you're using SR, in which S set is dominant. But here you have reset which is dominant. So this is called simple latching and unlatching. Now we are about to make this interlock circuit. So for that, the only difference is we have to take Q2 reset in parallel. Okay, so using one switch I1, one output is set, another is reset. So using I2, another is set and first will be reset. We're going to set this here. Q2 will be set and Q1 will be reset. Now both are open. Pressing I1, this lamp is set because this is a set command. Using I2, the other one is on, and again using I3, the first one is on, second one is on. So that's how you're doing interlocking using set. I hope this is very easy. You're just using set, reset, set, reset. You can do multiple set, reset of any number of outputs. It's pretty easy. You don't have to use NO and NC combinations here. This is one of the alternatives. Now using I3, if I have to reset both, I have to use I3. Okay, so my I3 is here. I can take RSQ2, P, paste RSQ1, simulation, run. Now this is interlocking. Alright, what's happening here is In the Schneider PLC, you cannot use RS2 twice. That's the problem. But in another PLC, you can use reset command as number of time you want. So in that case, you have to use I3 here to reset this one. And now, so the reason it should not affect this SQ1. So we'll put NC of this I3 over here. Okay. So you can take like this. And here also you'll take I3, so that if I'm pressing I3, it should not set the above command. We just want to use I3 to reset the output. That's the reason why I have used NC here and here as well. Oh. Now you'll see this is interlocking perfectly going on. This I3 is going to reset. Now why I have took this NC here? Because if I3 is turned on, this will give you a signal to RSQ only. Although the signal will go here because this is connected. But I have took this NC of this contact so that it will not pass this contact. It will not set the Q1 and Q2 parallelly here as well. That's why I have to take NC of here and NO of here, so that it should only affect the R2 reset coils of both the outputs. That's the reason I have to use I3 here and taking NC contact here to avoid getting its effect on SQ1 and SQ2. Okay, so this was interlocking and using set reset command, using latch, unlatch, or you can see that different commands. So that was all about the basic commands of Schneider: NONC, series parallel circuits, latching, unlatching, interlocking, set reset, and impulse command. We'll see further commands in further lessons.